In this example, we are trying to find the limit of this equation as x approaches 2. And so we have kind of a big mess going on, but we are going to try and see if we can use L'Hopital's rule, which basically means that, well, before anything, I'm just going to plug in the 2 and see, do we have a problem? If we have a problem, then can I use L'Hopital's rule? If I don't have a problem, then I have my limit and I'm done. So if I plug this in and I do all the math on this, I do end up getting a 0 over a 0, which is a scenario that we can use this. So we're going to do the derivative of the top and the derivative of the bottom, and then we'll plug the 2 back in again, see what happens. So we do the derivative of the top, that's going to get us a 3x squared minus a 6x. Top is done. Bottom, we have a 4x cubed minus a 12x squared plus a 14x minus 12. All right, so still potential that we get a 0 over a 0. So this is going to be 4. It's going to be a 12 minus 12. Probably most likely we're going to get a 0 over 0. Here we're going to get 8 times 4 is 32. And then we got 4 times 12 is 48 plus 28 minus 12. And we get, again, a 0 over a 0. So good news is we can do L'Hopital's rule one more time. I mean, we can do it as many times as we need, but don't go too far on it. So once you don't have a chance for a 0 in the denominator, that's when you stop and plug it in and kind of finish. So we do it again. So that's going to get us a 6x minus 6. And then here we're going to get a 12 x squared minus 24x plus 14. And then if I plug a 2 in, I'm not going to get a 0 on the top. So I'm going to go ahead and plug in. So we have a 6 times 2 minus 6 over the 12 times 2 squared minus a 24 times 2 plus 14. So we're looking at a 12 minus 6 over a 48 minus 48 plus 14. So we get 6 on the top, 14 on the bottom, which simplifies to 3/7. Right, so that was taking advantage of a L'Hopital's rule. Instead of trying to factor all these things and cancel out any kind of factors, we don't need to do that anymore. We can use this method where we do the derivative of the top, derivative of the bottom, plug it in, see if we can get a value. If not, do it again, plug it in, see if we're good.